Hi, I'm Kyle.
And I'm Tommy.
And this is Big Time Science.
Today we'll be doing a show on tornadoes.
Woo!
Sorry, I got
Sorry.
this.
Today, our show is going to be on weather with some info on tornadoes and atmospheric pressure.
We're going to start by making a barometer with a jar and a balloon, and hopefully it will change while we do the show.
Then we are going to make a tornado in a bottle. Well, actually we have already made it, but we are going to walk through how to make your own.
And finally, we're going to do a fun trick with atmospheric pressure and that involves water and a candle and, of course, food coloring.
You know I love food coloring because this means things might get messy. Let's get started.
Okay, first we're going to be making the barometer.
Yeah.
The things you need: a jar, a balloon,
Scissors, straw, and index card.
Process: tightly cover the top of a mason jar with a balloon. The balloon should be tight, making the can airtight. Place the straw horizontally sideways with the tape. Can you hold that thing?
Halfway.
That should be good. And then, tape the straw to the middle of the balloon so that it will not fall off.
Tape an index card to the wall behind the straw. The straw will act as a pointer on the card. Carefully record the location of the straw on the index card with a pencil. If desired, marks can be drawn on the index card to make observing the changes easier. After 15 minutes, record the new location of the straw on the index card. Continue checking and recording the straw location as often as you want. Explanation. High pressure will make the balloon cave in and the straw go up. Low pressure will make the balloon puff up and the straw go down. If possible, check your measurements with a real thermometer.
Which is right here. But we're just gonna use this thingy with the lines. So for the
No one cares about it.
yeah.
Kyle, write the numbers on the thing.
Oh.
Alright. I will write the numbers down.
Just go 1 to 20.
Alright.
Oh, but to make this, you just take a balloon. Okay, that wasn't supposed to happen, but you just take a balloon and you just cut it like right about here. And then you just take that, you don't need the part with the tie part. Take the part that you cut off and stretch it over the top of the jar. So yeah, that's how you put the balloon on the jar. So we're just gonna keep this like over here, and by the end of the show, we'll see if it changes.
Right now it'll be at 6, and if we go up,
It'll be at 1.
5 or 4.
So it's at 6?
Mhm.
And
Okay.
if we go down a little bit.
Just do a
So
little
see if
mark.
it changes.
Okay, that's a bad mark, but
That's
okay. Now, which one are we on? Oh, this one. Tornado cyclone. You will need 2 empty 2-liter bottles, or water bottles work good. Or these. Yeah. You fill
Oh, I gotta go.
water. Wait. You will also need water to fill the things about 2 quarters full, or not 2 quarters, 2/3 full.
No, you throw it
About a teaspoon of dishwashing detergent. This makes the simulated tornado have behave a little more realistically. Monopoly houses for a more realistic effect.
Food coloring makes a very interesting presentation. Glitter. What?
Yeah,
Glitter to simulate debris. Gorilla tape. If you can't find any, duct tape will do.
Yep, just like this one. It's wobbly. what you should do: take one 2-liter bottle and fill it about 3/3 of the way with water, about that much. Add a teaspoon of dishwashing detergent. This helps make the speed and behavior of the vortex a little more like the real thing.
You may also want to add food coloring, Monopoly houses, or glitter to watch what happens to the debris in a tornado.
Placing the 2-liter bottle directly on top of the 2-liter bottle that is filled.
You're right here.
I know.
You're like saying
Top of the 2-liter bottle that is filled.
Oh.
Place the tape around the bottle, like the neck of the bottle, like right here, since they're on top of each other. And so they're standing end to end. From experience, I highly recommend taping the bottles together very, very securely. They should not be able to move from side to side, but rather, when you handle them, they should feel like one bottle. I cannot emphasize the need to tape thoroughly enough.
give it a good twist or turn end to end and see what happens. What happened? If you watch the funnel as is formed and the way goes around, you are seeing a simulated tornado. If you happen to simulate any type of debris in your bottle, such as Monopoly houses, this little vortex sucks them up just as it would suck up real debris. What's a vortex? Like a real tornado, what you've created is a vortex. When air begins to spin very rapidly, it creates a vacuum in the middle. If you've ever watched water drain from a bathtub, you'll note that the center is empty while the water around it is spinning rapidly. It's also known sometimes as the eye. Oh, if you watch the news when there's a major hurricane, you'll hear lots of talk about the eye and the eye wall. The eye of the storm is the calmest part, while the wall of the eye is the deadliest, spinning the most rapidly.
And then this is what it looks like. It's just spinning. Okay, it's bubbling and then spins. Yep.
Do it a couple times.
So, yeah. To demonstrate atmospheric pressure, we are going to do a fun trick with a candle and blue water. For this, you will need a half a cup of water. Pour it into a small bowl. We're using a big bowl so it's easier to see.
Is that even one?
Yeah, I think so. So pour the water. That made a splash.
Oh my god.
Can I have some paper towels? Maybe a little more water?
Calm it down now. We should go back and show how the real tornado, how the real master does it. It's like in the Wizard of Oz. Like,
Do it again, but hold your hand on the bottom one so we can see it go down a little spaghetti.
It's just a bunch of bubbles.
no, oh my god. You want me to do it again?
Yes, I do.
Okay.
Okay, hold on the bottom one. Balance it. Wait, that one's pretty good. It was like up to here.
Okay.
It's fine.
We can go up. We
Okay,
can go
okay,
up.
continue.
Where
For this you'll need half a cup of water and pour into a small bowl. We just used a big bowl and see it better.
5 drops food coloring mixed into water.
Since you like food coloring.
Yeah, I'll do it now, Tommy.
What color? Red.
Wow. How many drops should I do?
It says 5.
Okay, I'll do 5 then.
Do 7.
What does it say 5?
It says right there.
Oh, I thought it said 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
It's gonna be blood.
It's gonna be blood. Do it. Okay, how do we mix this?
I'm guessing. Let's use this ruler.
Tommy. Oh my
This is
god.
nasty.
Should I put some yellow in there?
Make it orange.
Put some yellow in there.
That's called blue.
Let's do all of the colors.
It's gonna make it black.
Who cares?
Dude, it's black.
Who cares?
This is gonna look scary. Okay, it's literally black.
It's like a purple.
I'll do that. Oh, I guess we're doing black.
What the heck?
So now we finished all the colors. Let's just put that off to the side. Okay. Mix it up one last time.
Don't get on your shirts.
Hey, it's mostly green. Okay. Now we need to put the candle in the water, and then we put this. Oh, yeah.
We got
Lighter dude,
We
come here.
have our own fighter here. It's gonna come
Light
and
it
light
up.
the candle for us. Whoa, so awesome.
Give it a second. Get hot.
He
Get hot.
lit a candle.
Then we put the thingy over it. It's gonna suck up all the water.
Suck up the water. Suck up the water. I'm using the force. What are you, Star Wars? This isn't gonna work.
It's gonna work.
Force.
It's got to heat the air in the container and reduce the pressure. Read about it.
The force. Tea light, place in water in bowl. Parent. To light candle. We had. There it is.
And it's not heating anymore. Hey, you messed up the force. It's gonna go all the way up into the
Parent to
Not
light
yet, not yet,
candle.
not yet.
Well, we had our own person.
If it was
Tall,
still
narrow
lit,
glass-
it'd go up on the way.
Tall, narrow
It's not
glass
lit anymore.
jar
It's
or
not lit.
carafe. Put over lit candle in the water. This works because the candle heats the air in the jar and expands the air and causes the air pressure inside the jar to drop. Outside of the jar, the atmospheric pressure is higher and it is pushing on the blue water and causes it to go into the jar where the pressure is lower.
That's called master's work.
Do you want to do it again?
Yeah, it went out.
Well, it's going to go
it's
up
not
because it
even
uses up the
dry.
oxygen.
Right. The candle flame heats the air in the. This is from a book. It's from Cub Scout.
Yeah.
And heats the air in the bottle and expands it, pushing part of it out, making the water bubble. The air pressure inside the bottle drops. Outside the bottle, the higher atmospheric pressure on the water's surface pushes the water and the candle up into the bottle. The flame goes out when it burns up and all the oxygen in the bottle.
Oh, so Rory, come light it. Okay.
Lights.
I'm gonna put this back on. See if it works.
And now I will use the force.
Okay, let's both use the force. Maybe it'll go a little faster.
Go, I farted.
It's going faster. It's going faster. It's gonna lift the candle. It's lifting it. We're lifting the candle. And it's not working. Come on, forcey force.
Darn.
Here's all your power, Kyle.
He's a big candle. Yeah.
Please don't get the fuse wet.
Mm,
Okay. Experiment using two different sizes. This one and this one. Mr. Fire Dude, come here and light this. I command you to.
Roy, do it to the side, honey. So she
Hey,
can
wait a
see.
second. I wouldn't do that one.
Fine.
Yes.
Let it heat up a little. I'll do this one first.
No, I'll do this one.
Got a flat view. And I was doing that the whole time. I'm sorry. Wait.
Anyways, the camera's not even on me, so. Okay,
Do you
now
think it's going to suck up more water?
Oh, force. Use the force too. You can get more.
Tommy, what's your
power.
prediction?
It's gonna suck up more water.
No, it's not. It's gonna suck up less.
Yeah, that's what
It's
I
gonna
was
suck
thinking.
up more. Don't go out. Don't go out.
Well,
Don't go out.
more. Never mind.
Suck it up. Suck it up.
Suck it up.
Kyle, why do you think it sucked up more liquid?
water.
Hey,
Is there more hot air in there?
no,
Is
I
there
know where
more
more
space?
hot air is.
You.
We're gonna do it again, but this time it's pre-lit. Pre-lit. I thought we were doing the same one. No. Oh, okay. What if we put it in just a jar, no liquids? I think there's too much liquids. Let's go a little faster. No, that's not. And if you notice how every time it goes up the same level. Use the force. Lift, 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 lift. You are gonna pay for that.
Stop with the noises.
What is the flame doing inside there?
It's dying.
It's sitting there.
Why is it dying?
No.
Is it because it used up all the oxygen in the jar?
Yes. Yes, it
You
is.
can't even see the candle.
Don't die. Okay, I'm gonna. And drop. Okay, whatever. That doesn't matter.
Do you want to try the big one more time?
You're dripping stuff on my shirt. Jeez, Kyle. Jeez. Okay.
Did you just say cheese?
Yes, I said cheese. Of course I said cheese. What else would I say? Pie?
I'll just put it in there. I
Pudding?
don't need your sarcasm now.
I'm not being sarcastic.
But it sounded like it.
Okay. Oh, did you hear that noise?
Like I said. Rolling.
So you want to try letting the air heat up a little bit first?
Yes. Just gonna hold it here, see what happens. It's underwater. Oh, don't die, don't die. Oh, let it die. Okay.
5 minutes.
Relight it.
All right, you guys want to make this work the last time, and then we'll go on to the other part.
Oh, it's full of liquids. It's probably not gonna light. One second, let me dump it out. Let me dump it out. You're catching the food coloring on fire.
Oh, what the heck?
All right. Let's move to the next project.
No, one more time. One more time.
You almost
Okay.
killed me.
You burned me with the lighter. My pinky's gonna have to work. Okay, light it one last time. This should work. Now this time, don't die, my little friend. I command you not to die.
Then let the air burn.
Oh my gosh. That was weird.
It does. It stinks. Just gonna submerge it so it'll float better.
Tommy, it's gonna go out if you do that.
Yes, sir. So let it go,
I
Thomas.
guarantee you.
It's at the bottom.
All right. I think your candle's
Wait,
too
no.
dead. Oh,
Is lifting using the force.
Yeah, okay. It's done.
Alright, it's done. It's dead.
So listen, guys. You know what? Hold on. Don't.
Yeah, hold on.
Okay, Kyle. You'll notice how your barometer has actually changed, and now see what number it's up to.
This is wax.
5 and like we're up
Like
to
4.5, really.
No, we're up to about 5, 4,
Four, really?
3.5. 3.5.
All right. So get the blow dryer, Kyle.
I already want it. Hey, whoa, I'm doing no, this is my job. No.
Hey, Tommy, Kyle's gonna do it.
I'm doing this. Your job, whatever. Watch your feet. It's gonna go down. It's going down. As we heat the jar, the balloon is gonna go higher and the straw is going down. You can see it. Zoom in. It's already at 7, 8. We're on at 9. See, it's puffing up here. Puffing up.
They go on this on the numbers you can see on the chart. Yeah, see? Wow, that's a big difference.
So yeah, it's a big difference.
So see, put it back on the scale. Put it back on the scale. And go all the way, zoom all the way over the side.
It
like
was
that.
like
And you can see the
8, like 9.
what's it on there. It was up on the 3 and now it's on like the
9.
so that's a big change. So Kyle, read about what happened. Since Tommy's gonna wrestle instead of be part of the show.
Oh, okay, I'm back.
Oh yeah, one more thing.
Yeah? Refresh it. What's it on now? 9? No, 8.
Air pressure barometer is a very useful element when weather forecasting. We all know when we look at the barometer for high pressure in the summer and dread the low pressure coming in the winter. Change in the air pressure trend that is useful in the weather prediction. The trend is a rise in pressure. The change in air pressure is a I just read that part. Is a trend that is useful in weather prediction. The trend is a rise in pressure, then generally the weather will be improving.
One second.
Whereas
Whereas a fall in pressure,
it says whereas
whereas
a fall in pressure shows the
worsening shows a worsening
Got
outlook.
it.
A worsening outlook.
shows a worsening outlook. The
Gauge?
The gauge, yeah.
The gauge, I'm sorry. The gauge is used shows the actual reading along with the high and low point for the day, plus the pressure trend is indicated with an arrow. Arrow.
Tommy, read it. Tommy, read it. Go ahead, read it.
Air pressure is also part of calculation of dew point precipitation.
You almost had it over.
So are you guys good?
Yeah.
And what are you going to say? How do you finish your
I
show?
said arrow.
And then, I guess that's the end of the show.
Whoa.
Show us the barometer, the real one.
Oh, good.
Here.
Ironically, if we had the 8 a little higher, it would be exactly right by tens on your scale.
Huh?
If you had your 8, the next line up, it would be right on.
Wait, is this upside down? No.
Rory.
Well, today we learned about atmospheric pressure and barometers and how they tell you how much atmospheric, however you say it, pressure. And then I guess that's the end of the show.
How the right weather conditions can impact hurricanes and tornadoes.
And that how weather conditions can impact tornadoes and hurricanes. And I guess that's the end. So,
Bye, I'm Kyle.
and I'm Tommy, and this is all about tornadoes.